Okay, last time we practiced some MCQs questions from the topic of properties of alpha, beta, and gamma radiations, right? We discussed that what is the penetration power of alpha, beta, gamma, what are the ionization power of alpha, beta, gamma, and all other properties that what is the range, what is the speed, all these factors related to alpha, beta, and gamma. And now we all know that the nature of alpha is equals to the size of helium atom, and beta looks like the fast moving electron, and gamma is like electromagnetic radiation. The charge of alpha is +2, the charge of beta is -1, the charge of gamma is 0 because gamma is neutral, there is no charge on gamma. And as we discussed that in radioactivity process, if we consider any radioactive nuclei or radioactive element, so definitely that radioactive nuclei emits radiation from its nucleus. And definitely when something is like going to be subtract from any quantity, so definitely it starts to decrease, right? For example, if we have a nucleus and there are 10 number of protons and 10 number of neutrons, 10 number of electrons, so definitely when it starts to emit radiation, so the value will be decreasing from the value of 10. And for example, to understand this idea that how to identify the exact value, whenever like we got alpha radiations, beta and gamma radiations. So the topic is radioactive decay. Radioactive decay means we have three type of radiation. So definitely we have three type of decay, right? For example, the first one is
What is decay?
decay means to like decrease something from like any specific quantity, just like we discussed in radioactivity, that radioactivity is the random process that emit radiations from unstable nucleus, right? Or unstable nuclei. So, for example, if we have 500 ml of water bottle, right, that is completely filled 500 ml, and if we like make hole in it by using a common pin, right? So water starts to like rinse from that water bottle, and after some time, the quantity of water decreases in the water bottle because of that hole in it. So in the same way, when we talk about radioactivity decay, so radioactivity decay is just like the same because the mass of the atom, mass of the nucleus starts to decrease time by time. Okay. For example, if we have alpha decay, मतलब आपके पास जो ओरिजिनल मास होगा उसमें से आप थोड़ी थोड़ी क्वांटिटी जो है वो डिक्रीज करते जाओ, राइट? फॉर एग्जांपल इफ यू हैव 100 रुपी नोट और अगर आप उसको चेंज करवा के सारे 1 रुपी के कॉइन्स ले लेते हो और आप उसमें से एक एक करके 1 2 3 4 माइनस करना शुरू करो, सो डेफिनेटली आफ्टर सम टाइम उसकी वैल्यू जीरो हो जाएगी, राइट? क्योंकि आपके पास वो क्वांटिटी एक एक करके वहां से सब्ट्रैक्ट हो चुकी होगी. In the same way, for example, if we consider radioactive element, एक radioactive element है that is uranium, 92 atomic number, 235 atomic mass. और एग्जाम में ये एलिमेंट आपको खुद ही वो लिख कर देंगे. दे विल नॉट आस्क यू टू लर्न ऑल द इक्वेशन बाय योरसेल्फ, तो इक्वेशंस याद करने की जरूरत नहीं है. वी जस्ट नीड टू नो हाउ टू बैलेंस द इक्वेशंस यूजिंग अल्फा डिके, बीटा एंड गामा डिके. ठीक है, और बहुत इजी है. फॉर एग्जाम्पल दिस इज यूरेनियम एंड दिस इज रेडियो एक्टिव एलिमेंट, और वी कैन से दिस इज अनस्टेबल एलिमेंट. और इसमें से रेडिएशन एमिट हो रही है, राइट? ये अपना मास थोड़ा थोड़ा करके जो है वो डिक्रीज कर रहा है, डिके कर रहा है. सो रिजल्ट में क्या होगा? फॉर एग्जाम्पल इफ यू नो दैट दिस एलिमेंट डिके अल्फा पार्टिकल, राइट, और इसमें अल्फा डिके हो रहा है, सो अकॉर्डिंग टू अल्फा डिके वी नो दो प्रोटॉन के इक्वल होता है 4 नंबर ऑफ न्यूक्लियॉन्स होने चाहिए अल्फा में, बिकॉज इट इज इक्वल्स टू हीलियम। सो हीलियम के इक्वल होने का मतलब ये है कि अल्फा में भी 2 प्रोटॉन्स और टोटल 4 न्यूक्लियॉन नंबर होने चाहिए। और अब आपके पास इक्वेशन बहुत सिंपल है। नाउ यू आर गेटिंग समथिंग न्यू इन योर रिजल्ट, क्योंकि अब यूरेनियम तो डिके हो रहा है, राइट? मतलब यूरेनियम का जो मास है वो डिक्रीज हो रहा है। एंड डेफिनेटली व्हेन यू डिक्रीज द मास इक्वल्स टू द अल्फा पार्टिकल, हीलियम जितना मास आप इसमें से अगर माइनस कर दो, सो डेफिनेटली यू विल गेट लेस मास एज कंपेयर टू द ओरिजिनल वन। और इक्वेशन बैलेंस करना बहुत इजी है। यू जस्ट नीड टू डू subtraction like this. We got new element, any random element. We are not writing the name of that element, that is not important, ठीक है? हमें एलिमेंट्स के नाम याद नहीं करने। सो योर फाइनल एलिमेंट विल बी लाइक 92 -2 235 -4। ठीक है, तो ये सिंपल आपने सब्ट्रैक्शन करनी है। एंड फाइनली ये एलिमेंट आपको कुछ इस तरह का मिलेगा, 90 231। ओके, सो बेसिकली ये आपने सब्ट्रैक्शन शो नहीं करनी, दिस इज जस्ट फॉर योर रेफरेंस, बट यू जस्ट नीड टू राइट डाउन दिस फाइनल रिजल्ट, that is why 90 and 231. So you can see this process is very simple. You can perform alpha decay very easily. You just need to know the basic nature of alpha, and that will give you the final answer after the alpha decay, right? So alpha decay के बाद आपको final result में जो क्वांटिटी मिलेगी वो इस तरह से मिलती है। यू जस्ट नीड टू सब्ट्रैक्ट द नंबर ऑफ प्रोटॉन एंड नंबर ऑफ न्यूक्लियॉन्स फ्रॉम द ओरिजिनल न्यूक्लियस एंड यू विल गेट द फाइनल आंसर। In the same way, if we consider beta, so we know that beta are fast moving electrons. So according to that scenario, number two, yes.
Sir, we supposed uranium was not balanced, or it is already not balanced.
Okay, basically when we are going to perform any radioactive decay, right? So radioactive decay होगा ही सब unstable nucleus में और unstable nuclei में, right? So uranium is unbalanced, right?
In this equation, it is unbalanced.
Yes, unbalanced in the sense of radioactivity, right? क्योंकि आपको
Okay.
याद होगा कि इन रदरफोर्ड एक्सपेरिमेंट भी डिस्कस कि उसमें हमने अनस्टेबल एलिमेंट तो लिया था, बट टू मेक इट मोर अनस्टेबल उस पे हमने अल्फा पार्टिकल्स को जो है वो उसकी बम्बार्टमेंट करवाई थी, मतलब काफी सारे अल्फा पार्टिकल्स को गोल्ड फॉइल पे स्ट्राइक करवाया था, राइट? इसी तरह से अभी एटम बॉम्ब का भी जब हम डिस्कस करेंगे इक्वेशन, सो इन दैट यू विल सी दैट अगर एक अनस्टेबल न्यूक्लियस है और यू वांट टू मेक इट मोर अनस्टेबल ताकि उसमें रिएक्शन जल्दी हो जाए, ठीक है? मतलब आप चाह रहे हो कि रिएक्शन अभी परफॉर्म किया जाए, बट यू नो कि वो अपनी नेचुरल स्पीड से ही डिके होगा, बट यू वांट टू मेक इट मोर फास्टर, तो आप क्या करो उसमें और न्यूट्रॉन्स ऐड कर दो। सो व्हेन यू ऐड मोर न्यूट्रॉन्स, क्योंकि न्यूट्रॉन का फायदा ये होता है कि देयर इज नो चार्ज ऑन न्यूट्रॉन, सो इट कैन बी इजीली ऐड इनटू द न्यूक्लियस। प्रोटॉन होगा तो रिपल्शन अट्रैक्शन का प्रॉब्लम रहेगा, इलेक्ट्रॉन होगा तो इलेक्ट्रॉन का मास बहुत कम होता है, और डेफिनेटली इलेक्ट्रॉन ऑल्सो हैव नेगेटिव चार्ज, राइट? सो इन चीज़ों को ओवरकम करने के लिए आप इसमें इलेक्ट्रॉन्स और ऐड कर दो, जैसे आइसोटोप्स होते हैं। सो इट बिकम्स मोर अनस्टेबल और ये डिके जल्दी करना शुरू कर देगा बिकॉज ऑफ मोर अनस्टेबिलिटी, राइट? तो हम
Oh, I got
जितने
it.
भी, हाँ, जितने भी डिके की बात होगी, सो ऑल डिके प्रोसेस आर ड्यू टू अनस्टेबिलिटी in the nucleus of an atom. In the same way, if we talk about beta decay, so beta decay थोड़ा सा different है, because we know that हम number of electron कहीं show नहीं करवाते, right? So for example, if we consider same example uranium, 92 235, and it is going to be decay into beta particle -1 0। ठीक है। अब यहाँ पर mathematically if we apply the concept just like the alpha decay, so you will get result very easily, right? अगर आप simple इस पे वही subtraction वाला process apply कर दो, so you will get result very easily. For example, 92 minus -1, right? Because beta have negative charge, so -1, and 235 remains 235. So you can see your final result will be equals to 93 and 235। ठीक है। तो एक कॉन्सेप्ट ये होगा कि अभी तो हम बात कर रहे थे दैट ड्यू टू द डिके मास विल डिक्रीज और क्वांटिटी डिक्रीज हो जाती है, बट इन दिस इक्वेशन वी आर गेटिंग more number of protons, right? We are getting 93 number of protons according to this equation. So why this is happening? So basically what happens in beta decay, in beta decay we know beta is only fast moving electron. Okay, so in this situation एक सिंपल सा प्रोसेस आपने याद रखना है, बिकॉज दे आस्क क्वेश्चन इन पास्ट पेपर्स रिलेटेड टू बीटा डिके स्पेशली। इन बीटा डिके व्हाट हैपेंस दैट वन न्यूट्रॉन, you can see now neutron is less as compared to initial। पहले 92 प्रोटॉन थे और 235 minus 92 will be the number of neutrons, but in final result we have 93 protons, right? And number of nucleons are still same। तो जब आप 235 में से 93 को माइनस करोगे, सो डेफिनेटली यू विल गेट वन लेस न्यूट्रॉन एज कंपेयर टू ओरिजिनल वन, राइट? मतलब ओरिजिनल में 235 माइनस 92 था, लेकिन फाइनल में 235 माइनस 93 हो गया, तो एक प्रोटॉन इंक्रीज हुआ, सो डेफिनेटली योर फाइनल रिजल्ट विल बी लेस बाय वन न्यूट्रॉन। सो इन दिस सिनेरियो वी हैव
So
वन
how we
लेस।
have missed one less neutron?
Basically this is a natural process of beta decay, right? And we are only like going to understand that what is happening in this equation, why we are getting one more proton. Okay, so this is the question. Naturally it happens like the same, okay, but we need to discuss, we need to identify that how this actually happens and what is the reason behind it. So reason is very simple. It is happening because one neutron is going to be converted into one proton and one electron, because neutron is neutral. And if let's suppose if this one neutron is splits into one proton which is positive and one electron which is negative, right? So 1 plus, or you can say +1 -1, they can easily cancel out each other and they can neutralize each other. Okay, so when you add one proton, one electron, it gives you result 0, because both have opposite charge, and due to that opposite charge they like attract each other and they neutralize each other, and finally we got a neutral particle which is called neutron. So that's why we are getting one more proton, right? Because we have already electron in the equation, and we got one more proton. So this happens because in beta decay, one neutron converts into one proton and one electron. So that's why we are getting one more proton, because neutron converts into electron and proton. So the number of neutron decreases in final result and number of proton increases in your final result. Okay. So this happens only in beta, right? So when they ask about like the what is the structural change or what is the change in the structure of the nucleus after beta decay, so this is the change in the structure, that one neutron decreases because one neutron converts into one proton and one electron. and the number of proton increases, right, as compared to number of neutron. So this is the process of beta decay. And the final one is gamma. And you know gamma is neutral. Gamma decay. So if we consider same element uranium 92, so uranium 92, 235, it will give you final result 92, 235. Because gamma is neutral, there is no charge on gamma. So that's why we are getting same uranium in your result. But there is one difference in both uraniums, that before reaction, this uranium is more unstable, right? So this uranium
Why?
is more unstable, right? As compared to the uranium in your final result. So this is the difference, because radiations are emitting out in the form of gamma, right? Gamma is like electromagnetic radiation. So definitely radiations are coming out from the nucleus of uranium. So initially uranium is more unstable. It is like in more excited state. And when it emit out gamma radiations, so after gamma radiations, we got a stable state of uranium, right? So this is the concept of alpha, beta, and gamma decay, right? And in our question, when we practice the question, so definitely you will get a scenario related to these equations, and it will help you to solve equations very easily. You don't need to learn any name of element. You don't need to learn any specific number of any element. So you can just need to know the basic idea of alpha, beta, gamma, and you can easily drive your equation. Yes.
The
I actually,
gamma with uranium, you put a plus sign.
yes. Basically, this plus is like in final product. In final product, we are getting two things, right? One product and the second product, and they are equals to the initial element, which is given uranium 92. So that plus is only like the addition of two elements, uranium and gamma. Okay. That plus is
Okay,
not
sir.
for gamma. Whenever we used to write a charge on any element, so we used to write like you can see in the number of proton or in atomic mass. Okay. Otherwise, we will not write plus sign anywhere. Okay.
Okay, sir. I got it.
And sir, in beta decay, you said that we have one less neutron and it is
Mhm.
converted into one more proton.
Hmm. Yes, one
So
proton and one
the
electron.
yes, sir. So the mass, so the atomic mass, shouldn't it decrease by one as well, like 235, 4?
Basically that mass decrease. For example, in your bag, you have five books and five journals, right? And they are of equal mass, right? The mass of book is equals to the mass of journal. Now let's suppose from five book and from five journal, you like decrease the quantity of book. Now you have four books, but you increase the quantity of journal. Now you have six journals. So total quantity remains the same. So this is the thing that is going to be happen over here. Proton is
Ah,
increasing,
okay,
so
got it.
neutron is decreasing, but overall mass remains the same in the nucleus, right?
Okay,
So
so
this
can you
is the
wait
scenario.
here? I want to like note it down.
Okay.
Sir, can you repeat what you said again
Basically,
about
when
the?
yes, uh, when you are like working with the beta decay, so in beta decay, what happens? The total mass you can see that remains the same, 235, 235. So there is no change in the atomic mass, right? But
Yes, sir.
we got change in the proton number. Okay, so when one neutron converts into one proton and one electron, so we know that in nucleus we have proton and neutron. So if one proton increases, so and one neutron decreases, so it means they are balancing each other. So the original value of the mass of nucleus remains the same. Okay,
Okay, sir. I got it.
because if we increase proton and neutron both, so then your mass of the nucleus becomes unstable. Okay, but that
Sir, the 235 was the atomic mass.
yes, mass number or atomic mass. It shows you how many protons and neutrons together are there in the nucleus. Okay,
Okay, sir.
okay. Now after the concept, we will practice the questions related to this scenario. But before that, we have another idea. So then it will be easy to solve combined question of these topics because these topics are linked with each other. Next concept is also like related to this decay process, and that is called half-life.
Okay, so can you just scroll up till just where the gamma decay is visible? Only gamma decay is visible, so you can continue writing.
Okay. Okay, by name half-life, right? We can identify one thing, the word half. Half means to decrease something into two equal parts or into the half quantity of its original. For example, if we have 100, so if we divide into two equal parts, it will be 50-50. So that 50 is actually the half value of 100. So in the same way, we are going to do something similar, just like that concept of half in the in the topic of half-life, right? As we already discussed about alpha decay, beta decay, gamma decay. For example, if we consider example of alpha decay, so we only write equation for one time alpha decay, right? But this decay will continue to take place until the element becomes completely stable, right? So, for example, alpha decay in 1 minute, then after 10 minutes, one more alpha decay, then after 10 minutes, one more alpha decay, then after 10 minutes, one more alpha decay. So, alpha decay after uh fixed interval of time, right? Like after 10 minutes, for example, alpha decay from this uranium element. Okay. So now you can see the mass of alpha is subtracting from uranium, then another mass equal to alpha subtracting from uranium. So definitely your mass number and proton number are going to be decreased after every 10 minutes, right? So half-life or the concept of the half-life is just like the same. Okay. The word half means definitely the half value, and life means that if we want to identify, for example, if we take example of uranium, and when we need to find out that this is equals to 92, so there are 92 number of protons, right? And if we want to check that how long it will take to decrease this 92 number of protons into half, right? 46 for example, so how long it will take to decrease number of proton to the half of its original value, so that process is called half life, right? For example, we know that in example of cricket, there is a century, or century means 100 runs, right? And 50 means half century, right? So we know that half century is exactly the half uh, of the century, which means 100. So we need to find out in the same way that if we got the mass of any element, so how long it will take to decrease its original mass into half. Okay. So if we write down the definition, so there are two ways to write down the definition of half-life. The first one we will write the same time taken, because the word life actually explains the idea of time. For a radioactive sample to decrease radioactive nuclei to half of the initial value. So this definition is very simple. It half-life represents you the time taken for a radioactive sample to decrease its radioactive nuclei to half of the initial value. For example, if there is a radioactive sample, and for that radioactive sample the value is, let's suppose, 100. We are not writing exact proton number, neutron number. We are just taking the basic example. Let's suppose we have radioactive sample of value 100, and it takes total 2 years and after 2 years you observe that the mass of that element decreases to half. Okay. So now you got the value of half-life. It means after every 2 years, the value can be decreased into the half of its original value. Now we have 50. 50 means after 2 years, you will get a new value,
25.
25. So in the same way, you can see it will take like a very long time to completely decrease the mass equals to zero. So it will take long time, that after 25 you need to make it half, then more half, then more half. So it will take so many years to decrease this sample, and it will convert into the zero. And in the same way, uh, you can also write the definition of half-life in another form, and that definition gives you another idea also. For example, we can write definition time taken for the radioactive sample to decrease its activity to half of its initial value.
Sir,
So
this is the second definition.
yes, so these are two different definitions. And both definitions are important because in second definition you can see there is a term activity, right? That is written with a different color because the meaning of activity is very important to understand, because in your exam question sometimes you will get this term activity. So you need to know that what is the meaning of activity and why we are using this term activity. So the term of activity gives you the same idea basically. For example, if we define activity, so activity like a normal term, like we can perform different activities in our daily life. So this is the same thing, right? So activity means it gives you the idea of rate of radioactive emission from the sample, right? Rate means with respect to time. Rate word always means that we are comparing some quantity with respect to time. So word rate is very important to understand. Word rate gives you the idea that we are actually comparing something with respect to time. So in simple words, radioactive emission or radioactivity process with respect to time for any sample is called activity, right? Or in another words, yes,
Full form of WRT?
with respect to. In short form, we write WRT. In books also, like you may find this word WRT. WRT means in short we write with respect to time. Okay. Or if you find the first term difficult to explain for activity, you can like write down simple one. Number of radioactive emissions or radiations per unit time. So this is the same thing, right? The first definition for activity and second definition of activity, both are same, right? It's up to you. Whatever you find easy to explain, so you can explain the idea with respect to that definition. Okay.
So, sir, I have a question. Like, if they
Mhm.
are they gonna ask like the definition of half-life? So, are we supposed to write both?
No, you just need to write anyone. Okay, it's your choice. Okay, if you find the first one easy, so you can write the first definition, and if you find the second one easy, so you can write the second definition. Okay.
Okay, sir, I got it.
Yes. Okay. So this is the idea of the activity and the half life. Okay.